Problem 2, a concrete column give a cross section 18 inch by 18 inch and 24 foot high. It placed in 15 minutes. Calculate the resistance pressure distribution on the formwork. So that is the pressure. Assuming the concrete temperature is 70 degrees Fahrenheit. The unit grade of the concrete, so that is W, and the cement is the time 2 with a retarder, so that we can use table 13.13.2 to determine C sub C, the chemistry coefficients. So this is the column. How to determine the pressure for the columns? We need to go back to the equation we learned to determine for all columns. So you use the first equation, Pmax equal to CWCC 150 9000 R over T for all columns. So can apply regardless of the height, regardless of the rate of placement of the concrete. We use the first equation for all columns. So with that, you can see we can have the Pmax equal to CW C sub C 150 times 9000 R over T. So that is the equation we need to use. We need to find out what is given. So of course we have T, already have 70 degrees Fahrenheit. We need to find out the CW. What is CW? You see 160 pounds per cubic feet. So go to the final exam reference, 160 pounds. So that is, as you can see, if it's over 150 pounds per cubic feet, CW equal to W divided by 145. So as you can see that, so we can apply here equal to W divided by 145, 160 given 145. So you get that equal to 1.1. And then we can find out the CC, the chemistry coefficients. And the problem gives us is the cement is type 2 with a retarder. So go back to the final exam reference, table 13.2. So we have type 2, so the second line item with a retarder. So we have CC equal to 1.2. And as you can see, with a retarder, the concrete become more fluid. Pressure tend to be increased. That way CC greater than 1.2, as you can see there. Now what we are missing, we don't know the R, the rate of concrete. And this one, the rate of concrete is determined by the height over an hour. And this one, the column gives us to 24 feet high and placed in 15 minutes. So we can find out the rate of placement. For those of you missing what is the rate of concrete placement, you can go back to the concrete construction, the just previous lesson, we determined that. So here R equal to the height, 24 feet, and it done in 50 minutes. And because the rate determined by feet per hour, so we have 50 minutes, we just divide by 60 minutes per hour. So from that one, we can have 96 feet per hour. So everything already given, so we can, so the rate very fast, 96 feet per hour. So we have Pmax equal to 1.1 times 1.2 150 plus 9,000 times 96 divided by 70. So you get that is the 16,490 pound per square foot. And of course, it needs to be within the minimum pressure and maximum pressure. So the minimum pressure, the Pmax, it have to be greater than minimum pressure. 600 times CW, and that is 600 times 1.1. So you have that is 660 pound per square foot. Perfect. So 16,490 greater than 660. And then we have to be less than or equal to maximum pressure. And the maximum pressure equal to WH, and that is 160 for the W unit weight times H of this go equal to 24, and that is equal to 3,840 pound per square foot. So what does that mean? It means that the maximum pressure is less than the Pmax, so the Pmax get maximum at the maximum pressure, 3,840. So on that one, we can see that the maximum Pmax have to be equal to maximum pressure, cannot exceed that. So that should be the answer, not the 16,490 pound per square feet. So we always have to check that one, minimum pressure and maximum pressure. And similarly, because it's totally fluid, so as you can see, the same as the problem one when we set the determine the height of the maximum pressure, Pmax W S apostrophe equal to Pmax, and S apostrophe equal to Pmax over W. So you can find out the H apostrophe equal to Pmax over W. Pmax in this case only 3840 divided by 160. And then without any calculator, close your eyes, you can see it equal to the height of the goal, because that now it's WH, right? So that one it completely fluid. So we can draw the form for the goal, something like just exaggerate the thickness. That one, the goal is 24, the goal height is 24 feet, and with this case the pressure distributed linearly throughout until get Pmax at the end, at the bottom of the column, and 0 on top. And that one here, as you can see, it will be equal to 3,840 pound per square foot. So that is the distribution of the pressure on the go, the form will go for the columns. And that is problem 2.